Welcome to our channel Math and Math. Today we will solve a Csir Net problem on part B question. Therefore only one of the option will be correct. So the question is the radius of convergence of the power series. The power series is given, that is summation n running from 0 to infinity 4n to the power 4 minus n cube plus 3 into z to the power n. This is, so we need to find the radius of convergence for this particular power series. 4 options are given. Let us try solving them. So what's the formula for radius of convergence? So how do we find radius of convergence? We take the reciprocal of radius of convergence and we write it as 1 by r is equal to limit as n tends to infinity modulus of a n plus 1 by a n. So finding the result of 1 by r and then taking the reciprocal, we get back r. Let us write a n. A n is equal to 4n to the power 4 minus n cube plus 3. That is this. 4n to the power 4 minus n cube plus 3. That we have written here. This is a n. Let us replace in place of n plus 1 to get a n plus 1. So a n plus 1 will be equal to 4 times of n plus 1 to the power 4 minus n plus 1 whole cube plus 3. Now we can take 1 by r is equal to limit as n tends to infinity modulus of a n plus 1 by a n. This implies limit as n tends to infinity modulus of what is a n plus 1? 4 times of n plus 1 whole to the power 4 minus n plus 1 whole cube plus 3 divided by a n term 4n to the power 4 minus n cube plus 3 with the modulus sign. Now this implies limit as n tends to infinity modulus of, so here 4 into n plus 1 whole to the power 4. This can be written as 4 times of n to the power 4 into 1 plus 1 by n whole to the power 4. See here, if you multiply this term, you will get back the previous step as it is. See here, 4 times n to the power 4 into 1 plus 1 by n whole to the power 4. This we have. This can be written as 4 times n to the power 4. Here if you take the LCM, n plus 1 divided by n whole to the power 4. This is again 4n to the power 4, n plus 1 to the power 4 divided by n to the power 4. So n to the power 4, n to the power 4 gets cancelled. You get back 4 times of n plus 1 whole to the power 4, which is here in this term, isn't it? So we write this term as 4 times n to the power 4 into 1 plus 1 by n whole to the power 4. It's nothing but taking n to the power 4 common. So in case if you take n to the power 4 outside, you will be left out with n to the power 4 into 1 plus 1 by n whole to the power 4. So when you multiply and check, you will get the previous term back. So there is no problem in altering this term to this term. Okay. Now similarly we can write this term as minus n cube into 1 plus 1 by n whole cube. The last term will remain as it is plus 3 divided by denominator, let it be as it is 4n to the power 4 minus n cube plus 3. Now this is equal to limit as n tends to infinity. So here let us take n to the power 4 common. What do we get? N to the power 4, 4 times of 1 plus 1 by n to the power 4 minus, here if you take n to the power 4 common, here we have n cube. So that will be 1 by n into 1 plus 1 by n whole cube plus 3 by n to the power 4. See, this term you have to be very careful while taking the common. That is, When you multiply back, you have to get the previous step. So that if you check, then it will be easy for you. Divided by, here if you take in the denominator also n to the power 4 common, we get n to the power 4 into 4 minus of 1 by n plus 3 by n to the power 4. Close this modulus. Okay, now this n to the power 4 and this n to the power 4 gets cancelled. The next step will be, this is equal to limit as n tends to infinity 4 times of 1 plus 1 by n to the power 4 minus 1 by n into 1 plus 1 by n whole cube plus 3 by n to the power 4 whole divided by 4 minus 1 by n plus 3 by n to the power 4 inside the modulus. Now as n tends to infinity, what is 1 by n? As n tends to infinity, 1 by n will tend to 0, isn't it? So this term tends to 0, 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 here this term tends to 0, this term also tends to 0. So all the terms which has n in the denominator tends to 0. So this is equal to, now as limit n tends to infinity, what are we getting? Modulus of 4 times of 1 plus 0 to the power 4 minus, this will be 0 into 1 plus 0. So 0 into any term, that is 0, plus the third term is 0 divided by 4 minus 0 plus 0. So this is equal to 1 plus 0 to the power 4, that will be 1 to the power 4, that is 1. So modulus of 4 divided by 4, this is equal to modulus of 1. So we are not getting any negative sign. Since it is in modulus, whether it's positive or negative, that doesn't matter. That will be plus 1. We will be considering it as 1. This implies 1 by r is equal to 1. Therefore, what will be r? R is the reciprocal of 1. So, reciprocal of 1, 1 by 1, that is again 1. So, our radius of convergence is 1. In our option, we have option B as 1. So, this will be the correct answer. Let us just have a recap of the problem. So here we need to find the radius of convergence. So just take this term 4n to the power 4 minus n cube plus 3 as an, and write an plus 1. Then take 1 by r is equal to limit as n tends to infinity an plus 1 by an with the modulus sign. Then write down the terms. Then take the common terms, highest power of n, that you take it common in each term. In each term, take it a common, then try to cancel out in the numerator and denominator the possible highest power of n. Then take as limit n tends to infinity, whatever is the case. So as n tends to infinity, 1 by n tends to 0. So we are left out with, so here in this term, again don't write limit as n tends to infinity. So here we have, here itself we have taken limit as n tends to infinity. So this implies 4 divided by 4, that will be equal to 1. So 1 by r is 1, not radius itself is 1. So here we may have some other term. In case if we have 4, then radius of convergence will be 1 by 4. So 1 by r is equal to 1. So radius, take the reciprocal. So r will be equal to 1. Thank you.